A newly discovered comet will shine bright in the Hercules constellation. This year has been a great one for comets, and it's not over yet. Comet C 2023-H2, Lemmon, is passing close to Earth at the end of this month, offering a bright binocular or small-scope target you can enjoy nearly all evening long. The comet was last recorded at 6th magnitude, bright enough to see easily with binoculars, the larger the better, or a small telescope. It's likely to stay this bright, perhaps even reaching 5th magnitude, through the weekend, making it a ready target for Northern Hemisphere observers and astrophotographers. Lemmon is not currently visible in the Southern Hemisphere. It will be soon, though it will be fading. Comet C 2023-H2, Lemmon, was first spotted on April 23, 2023, by the 1.5-meter reflector telescope of the Mount Lemmon survey conducted from an observatory outside Tucson, Arizona, which is part of the wider Catalina Sky Survey. The comet is just one of an incredible 50,000 asteroids and comets discovered by the Mount Lemmon survey, making it one of the most prolific minor planet discovering surveys currently operating. This has been a good period to observe Comet C 2023-H2, Lemmon. On October 28, it reached perihelion, its closest point to the Sun, coming to around 83 million miles from our star. On October 31, the comet was visible edge-on from Earth with a stream of material observable project from the front of the Comet C 2023-H2, Lemmon. This was caused by radiation from the Sun causing solid icy material to turn straight to gas, a process called sublimation, which is also responsible for giving comets their distinctive tails. A comet is an icy, small solar system body that warms and begins to release gases when passing close to the Sun, a process called outgassing. This produces an extended, gravitationally unbound atmosphere or coma surrounding the nucleus, and sometimes a tail of gas and dust gas blown out from the coma. These phenomena are due to the effects of solar radiation and the outstreaming solar wind plasma acting upon the nucleus of the comet. Comet nuclei range from a few hundred meters to tens of kilometers across and are composed of loose collections of ice, dust, and small rocky particles. The coma may be up to 15 times Earth's diameter, while the tail may stretch beyond 1 astronomical unit. If sufficiently close and bright, a comet may be seen from Earth without the aid of a telescope and can subtend an arc of up to 30 degrees, 60 moons, across the sky. Comets have been observed and recorded since ancient times by many cultures and religions. Comets are important to scientists because they are primitive bodies left over from the formation of the solar system. They were among the first solid bodies to form in the solar nebula, the collapsing interstellar cloud of dust and gas out of which the Sun and planets formed. Comets formed in the outer regions of the solar nebula where it was cold enough for volatile ices to condense. This is generally taken to be beyond 5 astronomical units equal to 748 million kilometers, or 465 million miles, or beyond the orbit of Jupiter. Because comets have been stored in distant orbits beyond the planets, they have undergone few of the modifying processes that have melted or changed the larger bodies in the solar system. Thus, they retain a physical and chemical record of the primordial solar nebula and of the processes involved in the formation of planetary systems. A comet is made up of 4 visible parts: the nucleus, the coma, the ion tail, and the dust tail. The nucleus is a solid body typically a few kilometers in diameter and made up of a mixture of volatile ices, predominantly water ice, and silicate and organic dust particles. The coma is the freely escaping atmosphere around the nucleus that forms when the comet comes close to the Sun and the volatile ices sublimate, carrying with them dust particles that are intimately mixed with the frozen ices in the nucleus. The dust tail forms from those dust particles and is blown back by solar radiation pressure to form a long curving tail that is typically white or yellow in color. The ion tail forms from the volatile gases in the coma when they are ionized by ultraviolet photons from the sun and blown away by the solar wind. What makes a great comet? Orbits also play a key role as to whether a new comet discovery is destined for greatness or not. A good sign includes a perihelion either near the Earth in the inner solar system. Also, an intrinsic brightness while the comet is still far out in the solar system, suggesting a large bright nucleus, is another hopeful sign. We had two great lessons on this in the late 90s. First was Comet C/1995-01 Hale-Bopp, a large bright comet that was spotted while it was still far out in the solar system. Then, Comet C/1996 B2 Hyakutake, a smaller comet, crept up on us and passed close to the Earth. Sometimes even prosaic discoveries can have significance. One example is the recently discovered comet from the same Sky Survey 2023 S3 Lemmon, which shares some similarities with famous Comet 1P Halley. Comet S2 Lemmon has an orbital period exactly twice as long as Halley's comet at 152 years. And speaking of the most famous of all comets, 1P/Halley reaches aphelion next month on December 9 at $35 from the Sun, out beyond the orbit of Uranus. We're now midway between the last 1986 apparition for the comet, and the next perihelion in, mark your calendars, early 2061. Comet roll call for 2023 thus far includes Comet 1P/Encke, Comet 103P Hartley, 2023 P1 Nishimura, 2021 T4 Lemmon, 2023 E1 Atlas, 2022 E3 ZTF. Most of these fell in binocular range, though P1 Nishimura reached magnitude +2 near perihelion in September 2023. As of November 2021, there are 4,584 known comets. However, this represents a very small fraction of the total potential comet population, as the reservoir of comet-like bodies in the outer solar system, in the Oort cloud, is about 1 trillion. Roughly one comet per year is visible to the naked eye, though many of those are faint and unspectacular. Particularly bright examples are called great comets. Comets have been visited by uncrewed probes such as NASA's Deep Impact, which blasted a crater on Comet Tempel 1 to study its interior, and the European Space Agency's Rosetta, which became the first to land a robotic spacecraft on a comet. The first half of November will continue this trend, allowing skywatchers to continue to see Comet C/2023 H2, Lemmon, which will continue to be visible from New York City until around November 19th. At around this time, the comet's 3,870-year orbit around the Sun will begin to carry it away from the inner solar system. Discovered early this year, Comet C/2023 H2 Lemmon may approach naked eye brightness this month. A comet discovered earlier this year is performing above expectations, and is currently well placed in the dusk sky. We're talking about Comet C/2023 H2 Lemmon, moving up the charts now at magnitude +8 and brightening.